Hello, pre-AP Algebra 2. Welcome to a supplement to Lesson 15. Technically, a lot of what we're doing is really Lesson 16 and 17. But we're going to be getting down to the nitty-gritty. So what we're going to be doing is modeling relationships using polynomial functions. So you guys in Algebra 1 modeled linear relationships using a linear function. And now we're going to be able to actually model things that are quadratic, cubic, or even quartic. That is, that the degree is a fourth degree polynomial. Using our technology that we have, our calculators, and the graphing utility on those. So right now we're going to go back to 15, talking about fuel economy by speed. And we're going to enter that stuff into the calculator. So remember, when we did that, we were on our calculator. We wound up over here at stat. So you're going to hit stat and hit enter for edit. And we had a list in L1 and L2. L1, I believe, was our speed, and L2 was our gas mileage, right? So if you haven't entered that in your calculator quite yet, go ahead and take a moment to enter it now. I'll bring the list up for you so that you can. All right, so there we go. Hopefully you have that entered in there now. And we'll go ahead and look at this thing. Remember, once we had our data entered, in order to get our graph, we need to first make sure that we go to our, you can enter it from here, right? So right now my plot 1 is on. If it looks like that, it's off. I want it to be on, but in order to get it on, I'll hit enter. And make sure that that's bolded. Another way to do that is go to second, stat plot, and we can hit enter on 1 and make sure that that's turned on. We also need to make sure that our scatter plot is turned on. Our X list is at L1, and our Y list is at L2. I like the color blue. If you want a different color, that's fine. I think blue is kind of easy to see. So here we go. If I have all those things going on and I hit graph, I should get a plot here. If I don't, I need to change my zoom. I need to change my window. And if I hit 9, right, from this zoom menu, zoom stat, that's going to get me where I need to be. And I'm going to have this going on. So we looked at some functions already, right? And we saw that this thing resembles x to the 4th power, right? And we'll call that a quartic, right? So remember, we might have something like that for a quartic. It looks like the function has an even degree, right? But we've got something else going on here, right? It's flipped. So what is it that flips it? Remember we talked about if I have f of x equals x squared, right? Like this, then it would be the case that f of x equals negative x squared would look like that, like a sad face. Aww. Likewise, if this is approximately, if this is quartic, right? So if it's roughly f of x equals x to the fourth, and of course there's going to be some other stuff over here. Then in order to flip it, so if I was going to take this thing and flip it, this would be f of x equals negative x to the fourth, right? Just in the same way. Another thing that occurs is with our cubic, right? So this is going to be roughly cubic. So we would say f of x equals x cubed, and then some other stuff would definitely be after that, right? Because it looks transformed. Then it would be the case that if I was to do, I'm sorry, I'm going to have to draw this graph over here. If I was to have something that looked like this, right, that would look, what that means is that the coefficient is negative, right? And of course there's some other stuff there. All right, so those are some basic transformations that can occur to this. So looking back at our data, it looks like this is quartic, right? Meaning it's fourth degree, x to the fourth is somewhere in there. And then it also looks like the coefficient, the leading coefficient, I should say, right? So the coefficient of the highest degree, so our leading coefficient, is negative. Okay, but let's see what our calculator says about it, because our calculator will actually estimate a function for this relationship between speed and fuel economy for us, and this is how we'll do it. So first thing we'll do is we'll go to stat. So this stuff lives in our menu for stat. We'll go over to calc. And then we will go to, so I have linear regression. So that's if this data was in roughly a straight line. Quad regression, if it looked parabolic, we would use that. For cubic regression, we would of course use that if it looked like a cubic function, if it had the end behaviors of a cubic function. But I suspect this is quartic. So we're going to hit 7 or go down to 7 and hit enter. Our x list, or our independent variable, is in L1, and our y list, or our dependent variable, is in L2. We don't need to mess with this frequency list. I am going to store this equation into I'm going to store it into the variable v, right? So v is going to be equal to our equation for our function that models this data. All right, I'm going to go down here and hit calculate. And this is the equation that is going to we could use to roughly model this data. So in other words, what this equation looks like is so this here, this is going to be our coefficient of x to the fourth. And this is kind of nasty, but it looks like negative 0 point. Oops. And I'm just going to go ahead and round that 3 to a 4. X to the 4th, just because we're going to run out of room here. Plus 0.001 x to the 3rd plus my bad minus, right? Looks like that c is negative. So minus 0.081 x squared plus 2.571 x plus 0.0566. So that equation, we can call it f of x, is an equation that we can use to model that data. And remember, we stored it as v, right? We stored that thing as v. So if you have an 83 plus, you actually have to enter this into your calculator over here in y equals in order to get it to graph it. But if you have a newer one and it stored that variable for you, or it stored the function for you, you can just hit v, and what that's doing is that's graphing. It's actually entering all this stuff in there for you to graph it. So I hit graph. I'm going to hit graph. And there we go. So that is roughly what that thing looks like. Now, I'd like to zoom out so that we can see a little bit better what's going on. So let's go ahead and hit zoom. And I'm going to go to zoom standard. And we're not going to get much of a very cool looking graph there. It actually looks linear, which is weird. But that's just because, look, our scale is units of 1, but we only have 10 units, right? If you look at our actual data, right, we have an x coordinate of 75 and a y coordinate of 24, right? We're up here 60 and 31, right? So this is outside of the scale of that graph. So we're going to take a better look at it by zooming out. So I'll hit zoom and then go out. And I'll just leave that right there at the origin. And we're starting to get a bigger picture of it. And then we'll zoom out again. And there it is. Now let's do some interpretation. What does it mean when x equals 0? So we'll go back to this. So it looks like we have our function looks something like that, right? And what does this mean when x is 0? Well, that means you're going 0 miles per hour. And what's kind of weird is that we actually have an x-intercept that doesn't make a whole bunch of sense, right? Because if we look at our equation that we had, I'll have to bring it back up for us. Our constant value, our y-intercept, is 0.566, right? So this value tells us that when x is 0, our gas mileage, we should be getting, 0.566 miles to the gallon, which makes no sense, right? Whatsoever. But we could use this to make some predictions by plugging some stuff in. So I just wanted to show you guys quickly how to do that. And we'll do a bunch of this in class for our next class. I just wanted to have you guys ready to do it because I will put some data up on the board. And we'll talk about all the different things that we can do in order to model it. So thank you so much for watching. And I hope you have a good evening. Goodbye.